Hello everyone and welcome back to CSCI 210. This week we will start exploring the sensors on the M-Bot, and I have Lightning McBot along with me to help me explain those. Now the odd thing about Lightning McBot is he actually hears with his eyes and he sees with his chin. Now the sensor on the chin is a light sensor, and you will use that when you start programming him to follow a course. A course that being a black stripe on a white line. That's what this paper is for. This is what came with your robot. Okay, more on that later. But back to his eyes, which are actually his ears. Well, this is also appropriate because, like a bat, Lightning McQueen actually sees with his ears, in that he uses ultrasound just the same way as bats do to locate objects. Now, the physics of it is they use ultrasound, which is sounds higher than 20,000 hertz or 20,000 cycles per second. And they emit the sound, and they time how long it takes to come back to them. They do a little math, and they come up with how far away the object is. Okay. Switching to the website, talk a little bit on the more on the physics of the sound. Now, typical human voices are anywhere from 150 hertz to something like 300 or 400 hertz. Now, if you sit there and you look at that, if you look at 150 hertz, 150 cycles per second, you have a wavelength of over 2 meters. And this is part of the reason why it's hard to locate somebody purely from sound. It's because the wavelength is so long that you can't really pinpoint the source. Now, if instead of 150 hertz you use 20,000 hertz, your wavelength drops down to 17 centimeters, which is about 6 inches, which is a lot better. Now, a lot of ultrasound works in the 100,000 hertz range, and that's down to about 3 centimeters, which is about about a little over an inch. So that's the physics of why you have to use ultrasound. Now, the physics of the speed of it is that the transmitter lets out a sound, and it knows when it did it, and it times when it gets to the receiver. Now what happens, both of these are transmitters, both of these are receivers. And they can do this simultaneously, and there's a little magic with that, but we're not going to worry about that. Now what happens is that at the closest range, which is 3 centimeters, the time it would take would be 0.03 meters. We got to be consistent with the unit, times 2, since it's a round trip, divided by the speed of sound, which is 331 meters per second, which is about 1,100 feet per second. So it's taken about a 10,000th, takes about 10,000ths of a second. Now, Lightning has the technology. He can measure something that short of a period of time. You and I would be hard pressed, but he's able to do that, and he's able to use that to get around. Okay, so this is how the ultrasonic sensor works. Now on to making it work.